Hey champions, welcome to class. Hope you are feeling good and ready for something fun and interesting. Don't worry, we are going to chill and enjoy learning together. So no more waiting, let's dive in and make this a great session. Today our topic is periodic table and the properties of periodic table like radius, ionization energy, electron affinity and electronegativity. Before starting our today's class, we want to learn about Coulomb's law. So, my dear friends, this is an atom. This is nucleus of this atom, and you all know nucleus has positive charge, proton, and outer shell has electrons. Let Q1 is the charge of proton and Q2 is the charge of electron. And D is the distance between nucleus and valence shell, that means outer shell. And F is the attractive force between nucleus and valence shell. So now Coulombs show the relation between attractive force, charge of proton, charge of electron and distance. Coulomb says the charge of proton and electron is directly proportional to the attractive force between nucleus and outer shell. And the distance between nucleus and outer shell is inversely proportional to the square. That means square of the distance. That means if distance increases, attractive force will be decreased. And if the proton and electron, charge of proton and electron increases, the attractive force will also increases. Now we want to know what is the relation between Coulomb's law and our today's topic. This is a portion of periodic table. From this periodic table, we see that in a specific group, all elements has same number of electrons. For example, group 1A, all the elements of group 1A has same valence electron and that is 1. Similarly, all the elements of group 6A has 6 valence electrons. So, in a specific group, when you move down in a group, the valence shell electron remains the same. But when you move down, one shell added to the atom. How? Hydrogen has only one shell. From this figure we see that lithium has 2 number of shells, sodium has 3 number of shells. So when you move top to bottom in a group, number of shell increase by 1, but number of outer shell electron remains the same. So when you move down in a group, obviously the distance between nucleus and outer shell increases. That's why the attractive force decreases. This is the relation between Coulomb's law and group. Now, if we move left to right in a period, what do you see? Uh, all the elements of period 1 has 1 shell, and period 2 has 2 number of shell, period 3 has 3 number of shell. That means in a period from left to right, number of shell remains the same, but valence electron increased by 1 and number of proton also increased by 1. Because lithium has 3 proton but beryllium has 4. On the other hand, neon has 10. So when you move left to right in a period, number of proton increased by 1, that is Q1 is increased, and number of valence electron also increased by 1 because lithium has 1 valence electron, beryllium has 2, boron has 3 and neon has 8. So for when you move left to right in a period, Q1 is also increases, D remains the same because number of shell remains the same, but with the increase of Q1 and Q2, attractive force between nucleus and outer shell increases. That's why outer shell come closer to the nucleus and radius will be decreases. This is the relation of Coulomb's law and period from left to right in a periodic table. So my dear friends, now we want to learn definitions and basis of some topics like electron affinity. Here we see that one electron added to the outer shell of oxygen to form O minus and some amount of energy released. This is electron affinity. When an anion, when a non-metal in its gaseous state accept one electron in its valence shell to produce uninegative gaseous anion, some amount of energy released. This is called electron affinity. That means the element which accept electron first, its electron affinity will be higher. Now we see the definition. The amount of energy released during an addition of the extra electron to the atom of an element in the gaseous state, transforming it into a negative ion, is known as the electron affinity of that element. That means, similar to ionization energy, as the atomic radius of the molecules decreases, the electron affinity increases. So this is the reverse of atomic radius. And as the atomic radius increases, the values of electron affinity decreases, because with the decrease of atomic radius, nucleus feel more attractive force to the outer shell. So outer shell come closer, and it is it is very easy to accept electrons, and electron affinity increases from left to right in a period. But in a group, when you move down in a group, the atomic size increases, so nucleus feel less attractive force to the outer shell, so electron affinity also decreases. So my dear friends, now we we want to see the ionization energy. Here, sodium has, here we see sodium has one electron in its valence shell. When sodium lost this electron, what happened? Sodium formed Na plus. So the amount of energy needed to remove one electron from outer shell of a metal to produce a gaseous unipositive metal ion is known as ionization energy. That means, if the atomic size decreases, nucleus feel more attractive force to the outer shell, and we need more energy to remove electron. That's why in a period from left to right, ionization energy will be increased. And in a group, when you move top to bottom, the outer shell um, goes far away from the nucleus, so attractive force decreases, and we need less energy to remove electron from outer shell, so ionization energy will be decreases. So my dear friends, here we see the definition of ionization energy. Ionization energy is the amount of energy required to remove electron from outer shell in its gaseous state and transform it into positively charged ion. The ionization energy of an element is influenced by its atomic size. When atomic radius is smaller, that means in a period left to right, the protons of the nucleus exert stronger force of attraction to the electrons, requiring more energy to remove electron, and ionization energy will be increases. And with the decrease of atomic, therefore, as the atomic radius decreases, the ionization energy will be increases. So, my dear friends, and the atomic radius will be increases, the ionization energy will be decreases. So we can say that when you move top to bottom, ionization energy will be decreases, and when you move left to right in a period, ionization energy will be increases. Now, electron negativity. When two non-metal form covalent bond, they share two electrons. The tendency of element to attract these bonded electron pair of electron towards itself is called electronegativity. Here two atoms attract these two electrons, and what happened? B attracts more, so B form partially negative ion, and A attracts less, so B produce partially positive ion. So the tendency of an atom to attract the electron pairs toward itself is called electronegativity. This is also the reverse of atomic radius. The atom which has smaller size can attract this electron pair more easily. So electronegativity will be increases. Now we see the definition. The ability of an atom to attract electron is called electronegativity. The electronegativity of an element is influenced by its atomic size. When the atomic radius is smaller, the proton of the nucleus exert a strong force of attractive force towards the valence electrons. Therefore, as the atomic radius decreases, the electronegativity also increases. And as the atomic radius increases, electronegativity decreases. Now, my dear friends, we see what happened when we move left to right and top to bottom. Atomic size increase or decreases. Generally, when you move top to bottom in a group, atomic size increases, and in a period from left to right, atomic size decreases. As you see from this figure, this is also shows the same scenario. When you move top to bottom in a group, atomic size increases, and left to right, atomic size decreases. Now, how can we write, yeah, in your answer script when you face such type of questions like why atomic radius decreases in a period or increases in a group? Now see the style we can answer this type of question. Here, when you move left to right in a period, number of shell remains the same, but valence electron increased by one. One proton added to the nucleus and one electron added to the outer shell. So, my dear friends, here is your answer. Number of shell remains the same. When you move left to right in a period, number of shell remains the same. Number of outer shell electrons increased by one. With the increase of outer shell electron and proton in a nucleus, according to Coulomb's law, the attractive force between nucleus and outer shell increases. So outer shell come closer to the nucleus, atomic radius decreases. This is the relation of atomic radius and Coulomb's law. Now we need more energy to remove electrons from outer shell because the attractive force increases. So ionization energy will be increases from left to right, and electron attracting tendency increases because atomic size decreases. So electronegativity also increases from left to right in a period, and electron accepting power, that means electron affinity, is also increases because the attractive force between nucleus and outer shell increases. That means from left to right in a period, the atomic radius will be decreases, but all these three are increases: ionization energy, electronegativity, and electron affinity. So, in this way, we can write why ionization energy will be increases, electronegativity will be increases, and electron affinity will be increases, and atomic radius will be decreases from left to right in a period. Now, when what happened when you move top to bottom in a group? The number of valence shell electron remains the same, but number of shell added by one. So when you move top to bottom in a group, a new energy level added to the atom. Number of outermost shell electrons remains the same. The addition of new energy level results in the increase in the size of the atom and decrease the atomic radius. Sorry, increase the atomic radius. That means outer shell distance between nucleus and outer shell increases. So the attractive force between nucleus and outer shell decreases according to the Coulomb's law. With the increase of D, attractive force will be decreases. So what happened when you move top to bottom in a group in case of ionization energy? Ionization energy will decreases because we need less energy to remove electron from outer shell. Why we need less energy? Because attractive force decreases, so we easily remove electron from outermost shell. So ionization energy will decreases. And what happened in case of electronegativity? Electronegativity also decreases because electron attracting tendency decreases. Why electron attracting tendency decreases? Because attractive force decreases. Valence electron and nucleus has far distance apart, so they feel less attractive force. So electron accepting and electron attracting tendency both are decreases from top to bottom in a group. That's why electron affinity also decreases. So my dear friends, so easy. Just you need to understand properly. Now, in short, we can represent our today's topic is top to bottom. That means in a group, what happened? Radius increases, ionization energy decreases, electronegativity decreases, electron affinity also decreases. And in so, my dear friends, what happens when you move left to right in a period? Atomic radius decreases. With the decrease of atomic radius, ionization energy increases, electron affinity increases, electronegativity also increases. So, my dear friends, today we learn four topics: radius, ionization energy, electronegativity, and electron affinity.